4.1, graphing quadratic functions in standard form. This equation, y equals ax squared plus bx plus c, is the standard form of a quadratic function, okay? What is the equation that we use for a linear function? Y equals mx plus b, right? Okay, so we use y equals mx plus b. I'm going to erase this in just a second. The b is what on my linear function?
The intercept.
The intercept, okay? The c is my intercept, okay? So anything that doesn't have an x with it is always my intercept in these equations, okay? Remember it that way. The m is my slope, right? And the slope does what to my graph on a line? What's the slope tell me? It does tell me if it's positive or negative, okay? It also tells me like, what is slope when we find it? It's what over what? Rise over run. So it's telling me how far it's rising and how far it's running, right? Okay. The a on a quadratic function tells me if it's positive or negative, and it tells me how far this graph is going to stretch or shrink, okay? So they're kind of the same thing, okay? And then the b, we're going to talk about that in a little bit in front of that x, what that goes with, okay? So a quadratic function is, do you know what this shape is? Do you remember what that's called? It does start with a P, yes.
Parabola?
It is a parabola, good. So a quadratic function makes a parabola. Okay, so when you are graphing something that's quadratic, you're going to have a parabola, okay? It's going to be a U shape, a nice curve, okay? When you graph a parabola, this is the parent function. Remember how we talked about parent functions of linear functions too and compared it to those? Okay, my parent function, the easiest form of my parent function is y equals x squared, okay? Because if I plug in a 1 to this, what do you get out? A 1. If I plug in a 2, what do I get out?
4.
Good. If I plug in a -2, what do I get out? I get a 4.
You get a 4.
I get a 4. Negatives.
Cool.
Okay.
No, I correct myself.
Good call. Okay, so what it's doing is, I start with this vertex of 0, 0, because when I plug in 0, I get a 0 out. That's my vertex. It's my turning point. And when I plug in a 1, I get a 1 out. It mirrors itself. Okay? 2 goes to 4, 2 to 4, and it's mirroring itself through what we call the axis of symmetry. In this case, the axis of symmetry is what? What is that line called there? What specific line is that on a graph? The y-axis, okay? So in this case, the axis of symmetry is the y-axis. But my axis of symmetry always goes through my vertex, okay? So it doesn't have to be the y-axis, okay? Axis of symmetry goes through vertex. Okay, you have to remember that. So everything's going to be mirrored over that. So if I find what my output is when I input the number 2, when I input the negative value, it's going to have the same output because it's a quadratic function. It's going to mirror itself. So I can find the vertex, graph it. I can plug in one other point next to it, graph it, reflect it, and I have my whole graph. That's all I have to do once we get into it a little bit, okay? But today, we're going to graph these by doing these 4 steps. We're going to take a little bit more time until we get used to it, and then we can simplify it down, okay? So it wants us to graph 2 things. It wants us to graph y equals 2x squared, and it wants us to graph the parent function so that we can compare them. Remember how we did that with other functions? We graphed them all in the same thing. I said use 2 colors, and we compared them that way. So we're going to make a table of values to do this. Now, that first graph, y equals 2x squared. What does that 2 tell me?
It's being multiplied with the x squared.
It is. So what's it going to do to that graph probably? Stretch it. It's going to make it wider, okay? It's going to make it wider. So it's going to, well, not wider. It's going to stretch it, which makes it skinnier. If I shrink it, what type of number would have to be in front to shrink it? See if you can think of that. if I have whole numbers and they stretch it,
Oh, it's a decimal or
a decimal or fraction, beautiful. That's going to shrink it and make it fatter, okay? So shorter, fatter,
Because it's divided
taller,
technically.
longer, okay? Good. So we want to make a table of values. What type of numbers do you think we want to plug in? To X and so on.
One, two.
Okay.
Oh wait, isn't this the 0, 1, 2, or 1, 2?
Yes, 0, 1, 2, and what other numbers are we going to plug in?
-1.
-1 and -2. Beautiful. If I could write, that would help. Okay. So we're going to start with these and see if we can see what happens to it. If I plug a -2 into this graph, I have y equals 2 times -2 squared. What's -2 squared?
4.
What's 4 times 2?
8.
So I get 8 out, okay? If you plug in -1, what do you get out?
4.
No. What's -1
Oh,
squared? -1 squared is
1.
1. 1 times 2
2.
is 2. If I plug in a 0, what do you get out?
0.
Beautiful. 0. Okay? If I plug in a 1, what do I get out? Okay, you see how this is mirroring right here?
Yeah, good.
Okay, and so what do you get if you plug in a 2? 8.
8.
Because it's going to mirror this side. So that means that 0, 0 is my what? Vertex. Good. So I'm going to graph 0, 0. That's my vertex. I want to label it. Then I'm going to graph -2, 8, right? -2, +8. I know that I made this. And then 2, 8. And then I'm graphing 1, 2, -1, 2.
So you,
Okay? Yes.
oh, okay.
So make a table of values, plot the points. That's what we did. Now what are we doing?
Cross me.
Okay, this is not a V, because what type of graph is a V?
That's a
Starts with an A. It's your favorite kind like this.
absolute value.
Yes, absolute value. Okay, so if you make a V, it's not right. Because we're not graphing absolute value, we're graphing quadratic. Quadratics like to be curvy, okay? So you're gonna be better than I am and graph this on graphing paper so it'll be easier. And you're gonna curve it, okay? Nice curved lines. So there's the graph of that. Now I want to compare it to the parent function. What do you know about the parent function? How can we graph that? Where's the vertex start at?
0, 0.
0, 0, okay? If I plug in a 1, what do you get out?
1.
Okay, if you plug in a -1, what do you get out? 1. If I plug in a 2, what do you get out?
4.
4. Okay. 2, 4, which means if I plug in a -2, what do I get out?
4.
Beautiful. Okay. So I have enough points that I can graph this parent function. Okay, now, halfway there. How do those graphs compare in words?
The green
Multiply.
Parabola.
Shrunk by
Stretch.
Stretched.
stretched by
Good. By 2 units. That's all that happened to it. So that's all you have to write. Okay, so I want you to graph them both so that they compare on a graph, and then I want it written in word form. So you can tell.
On the test, so we have to do it.
Word and in graphing, yes. Yes, you will, okay? So I wanna see those on all of them. Let's get used to doing it that way. Cool? Okay. Now we have another one. We have 2 over here. Okay, I'm gonna make this one in green again so I don't confuse you. And then we're gonna make this one in blue again, the parent function, okay? Okay, so let's talk about the blue one. What do you notice about the blue equation before we even make a table? What do you notice?
there's a fraction.
There's a fraction, so what's gonna happen to it?
It's going to shrink.
It's gonna shrink. What else is in front of that fraction? So what's it gonna do?
Upside down.
Yes, upside down. And what does that 3 tell me at the outside?
It's going to go move to the right.
No.
Move
To the left.
No, listen, think.
Oh.
The C goes with the Y intercept. So what does that mean? It moves up. Moves up. Good. Good, good, good. Okay, so make a table. Let's do our same little numbers. Okay. X, Y, we're going to do -2, -1, 0, 1, and 2. Okay. So this time I'm saying Y equals -1/2 times -2 squared plus 3. Okay. -2 squared is what?
4.
4. What's 4 times 1/2? -1/2?
-2.
-2. And what's -2 plus 3?
1.
Okay. So we have this.
Do we have to show all that, like, work, or do we just want?
What do you think?
Yeah.
Probably right, yeah.
Probably a good idea. That way if we mess up, we can go back and fix it. Okay? Good idea. So there we go. Now let's plug in a -1. Y equals -1/2, -1 squared plus 3. Okay. -1 squared is 1. Okay. 1 times -1/2.
Negative.
-1/2. Ooh, -1/2 plus 3. 2.5. And you can put it in decimal form if you want. Okay? 2.5. Now, listen. Since this is a parabola, what do we know about 1 and 2?
You'd be the same.
They're the same. So do I have to do math for those ones?
No.
No. So what does 1 come out to be? No? 2.5.
Oh.
What does 2 come out to be?
1.
Good. Now let's plug 0 in. I have Y equals -1/2, 0 squared plus 3. 0 squared is 0. And 0 times -1/2 is, so I have 0 plus 3, which equals?
0.
Okay. My next step is to do what with those points?
Plot 'em.
Plot them. So I'm going to 0, 3. 1, 2, 3. Ooh, look at that. That's now my what?
Vertex.
Vertex. Do you see how my vertex shifted?
Yes.
Okay? So this right here tells me how my vertex shifts. Okay? Now from there, I'm going to graph 1, 2.5, right? 1, 2.5, -1, 2.5. I'm going to graph 2, 1, yes? And 2, -1. Now, is that facing down?
Yes.
So we did it right.
Yes.
Okay? Beautiful. So now we just make our nice little smooth curvy lines because I'm on a whiteboard and it's not fun. Okay? On your homework it'll be nicer because you'll use graph paper, yes?
Yes.
Now, what do I have to do next?
Compared to the parent.
Okay, compare it to the parent function. Where do I graph the parent function's vertex?
0, 0.
0, 0. Good. And if I plug in a 1,
Wait a second.
okay, what?
I messed up on the points.
What do you mean you messed up on the points?
I put them, okay. Okay. Don't worry, I got it.
Okay. So the vertex is 0, 0. If I plug in a 1 for the parent function, I get what out?
1.
Okay, this is just something we're going to memorize. If I plug in a -1, I get 1. If I plug in a 2, I get 4. Okay, so basically we can have this parent function pretty much memorized. And I make this nice little graph. Okay. Curve it as much as possible. There we go. Now tell me in words what happens. How does the green parabola compare to the blue parabola? You've told me all along.
The green parabola shrunk.
Okay, shrunk by what?
3.
Mm-mm.
No, not half.
Shrunk by a half.
Half.
Okay, by half a unit. What else?
How do you say it went up? Do you say it just went up?
Say the vertex.
The vertex went up 3
Okay.
units.
Shifted up 3 units. What else?
And if
Okay. Beautiful. Good job.
So if there's more information and we didn't put it in that, like, so if we put like,
Then you get partial credit, but not full
So
credit.
you want the, like, all.
So
I
you
want
want
everything that happens to.
Okay.
Be as specific as possible. Tell me everything that's going on, okay? I'm gonna actually erase this part in a second because we're gonna do one more after I explain this. Okay. Properties of the graph y equals ax squared plus bx plus c. Here's the deal. If I want to graph a parabola and it's more complicated than this form and this form, because what are these forms missing from them? This is missing two things. What is it missing?
A B.
A bx and a.
C.
Okay. What is this one missing?
BX.
A bx. Okay. If it has all three parts, we're going to talk about how to find that a little bit easier. Okay. If it has all three parts, to find my vertex, okay, I have to set up an equation that says x equals the opposite of b over 2a. So this is to find vertex. And it doesn't matter if your graph is facing down or up, it's the same equation to find your vertex. Okay? Now listen, when I plug that in, when I take the opposite of b over 2a, I'm going to get the x of my vertex. What am I missing of the vertex?
The Y.
So what do you think I need to do with the x?
Plug it back in.
Plug it back in, okay? So you find it first and then you plug it in. Okay, and we're gonna do one of those. Now this is just a fancy way, this like big explanation of y equals ax squared plus bx plus c, a is greater than 0. It's a fancy way of saying if a is greater than 0, if this leading number is greater than 0, it faces up. If it's less than 0, like this one, it's going to face down. That's a fancy way of saying it, okay? You know that. You know if there's a negative sign, it flips. You know if it's positive, it stays up, okay? I'm going to erase this and we're going to do one more. And then we'll be done. Okay, practice this. Let's say you have this equation. It wants us to graph. We're not comparing it, we just want to graph. It wants you to graph y equals 2x squared minus 8x plus 6. Okay. Step 1. Find your vertex. How do you find your vertex?
X equals negative B over 2A.
Right. X equals negative b over 2a. What does that look like? What's my b?
Negative 8.
So what do I plug in? 8. And what's my a?
2.
Good. A, B, C. Beautiful. So what's 8 divided by 4?
2.
Now what do I do with that?
Plug it back in.
Okay. So I'm going to plug x in. So I'm going to say y equals 2 times 2 squared minus 8 times 2 plus 6. Oh, okay. What is 2 squared?
4.
4 times 2 is? What's negative 8 times 2?
Negative 16.
Negative 16 plus 6. Okay, combine like terms. 8 plus 6 is 14. So I have 14 minus 16, which gives me what? So my vertex is 2, negative 2. No longer on 0. Okay? I'm going to graph it over here. I need space. Okay. So I'm going to just go ahead and graph that vertex. So I'm going to graph 2, negative 2, 2, negative 2. What do you know about this graph automatically? Which way is it facing?
Up.
Up, okay? So as long as my points graph someplace up here, next, we're good to go, okay? 3. Step 3. If your vertex, if the y is not 0, we're going to plug in a 0 to find the y-intercept, okay? Because it's an easy number to plug in, right? Okay, so I'm gonna say, y equals 2 times 0 squared minus 8 times 0 plus 6. So I get what?
You get 0. plus 6.
So I get 6. So if I plug in a 0, I get positive 6, right? Let me change this color. So 0, 1, 2, 3, 4, 5, 6. What am I gonna do with that point? Reflect it. Good. So I reflect it. It is 1, 2 units away, 1, 2 units. So I reflect over here. And then you draw your parabola.
Wait, where's the, aren't there supposed to be 4 points?
True. When you're making a table, you're gonna make 4 points. When you're making it off of the standard form equation, you can literally find the vertex, find 1 point, reflect it, and draw your graph. Okay, makes it much easier. You have to remember to find your vertex, you have to use the opposite of b over 2a.
And then you just plug in the 0 for both A and B.
Yes.
Fine.
Yeah, as long as your vertex is not on the y-axis, you can plug in a 0.
What if it's only y-axis?
Then you're gonna plug in a number next to it. So if for some reason my vertex was right here, I would plug in a 1.
Okay.
Okay, plug in the next easiest number, the number closest to the vertex. Okay? Okay, so we're going to do this for homework. And we are going to do this again tomorrow for homework.